Assalamualaikum and a very good day. We are from Group 2. We are going to present about our project, which is the DC drive motor circuit. My name is FIRDAUS. What is a motor driver? A motor driver is a small current amplifier whose function is to take a low current control signal and then turn it into a higher current signal that can drive a motor. The basic purpose of the DC-DC conversion is to change the DC voltage level. It could also be used for insulation purposes. Generally, the DC-DC converter is the core of any converter. Next, I will let my partner to present about the next part.
Alright, you guys can see my screen, right? Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NAZIRULNAIM bin SHAHIDAN. I would like to talk about our mini project. So for the circuit. And as you can see on my screen, we use a Proteus. The first step is we convert the AC current into DC current. So the first block will be the DC bridge rectifier. So from the step down AC circuit from the transformer, we transform the AC into DC. But there's a drawback here. You can see that at the DC voltmeter, the output voltage was quite high and also very unstable for the rectifier output. So from here, we generate the output voltage into our next sub-circuit, which is the buck converter. So the buck converter, the purpose of the buck converter is to convert an output voltage into a stable and constant rate. To allow this, we use a duty cycle generated by the Arduino here. So this is the Arduino Uno 3. We control the duty cycle through the pulse width modulation, the PWM, by controlling the potentiometer here. So as you can see that I can increase the value of potentiometer and also decrease it, and we can generate a higher voltage. So for the DC motor, we need to generate around 12 to 13 volt. And this is an example for the buck converter. And here you can see the output pin here. There's a 12 volt. From here, we generate the output buck converter into the motor driver using the IR2112 here. So from here, the function for this circuit is to convert the low voltage pulse, which enable us to control the DC motor here. You can see that from here, the input pin from Q1, Q4, Q3, and Q2. You can find here around this one. You can find this on Q3 and Q2, and also at this for Q1 and Q4. The reason why we have two similar circuits is because we can generate two different polarity. One is for the reverse and forward. We're using the IR450, which act as switching devices, so that we can control the movement and speed for the DC motor. Either we can change it to the forward and reverse bias. And now I would like to pass on to our third teammates.
Assalamualaikum. My name is Muhammad Ilman. I will be continuing presenting about
I'll stop presenting. Alright, carry on.
So I will be presenting about our project coding. So this is our coding. As you can see, we are declaring our switching S1, S2, S0 in pin digital 0, S2, S3 and S4 in pin digital 1. So LED pin in pin digital 6. So this is port pin. Port pin is stand for the rheostat and potentiometer pin. So we put it as analog pin A0. So INT input, INT LED value. So this is our setup. So we declaring which is the output. So pin mode LED pin is the output, which is in the rheostat. Pin mode S1, S2, S3 and S4 is for the switching in quadrant 1, 2, quadrant 3 and 4 for the reverse and forward motor. So is the output for analog read. So it will read the potentiometer or rheostat reading when we setting. So this is a LED map for setting for scale for Arduino to 555. So this is the digital write. So when switch S1 and S2 is at high, so the digital write for S3 and S4 will be low. So and in the other hand, when switch S1 S2 is low, the digital switch the switch for S3 and S4 is high. So as you can see, this will be result in reverse and forward switching motor. So this is our motor. As you can see, we put delay for 1 second, and then after 1 second it will switch back to another reverse polarity. And as you can see, the motor is turned to the reverse position. And that's all for us. Thank you.